Hello, and this video is the continuation of the previous video in which we were discussing about the addition reaction of alkene, and we were talking about with example of addition of hydrogen halide. Addition of hydrogen halide or HX, and HX can be HCl, HBr or HI. And we learned that if we are adding two symmetrical alkene, then the hydrogen and halogen will go across the double bond, but which goes where is not an issue because the symmetrical alkene will have the same product in either case. But if we are adding across the double bond in unsymmetrical alkene like this, say for example, we are adding HCl, then it will follow the Markovnikov rule. And according to Markovnikov rule, when we are adding hydrogen halide across a double bond, then the hydrogen will go to the carbon containing larger number of hydrogen, and halogen will go to the carbon containing less number of hydrogen. Okay, so across the double bond, see this is the carbon that has one hydrogen, and this carbon has no hydrogen. So when we are adding HCl, the hydrogen will go to this carbon here and halogen will go to this carbon. So the result here will be hydrogen adding to this carbon and halogen adding to this carbon. And again, this Markovnikov, we call that as the Markovnikov product. And this formation of this as a major product, this is the major product. The other possible product is the minor product, in which just the opposite to that happens here. But this formation of this major product is the direct consequence of the mechanism. Right, from the mechanism we can clearly understand why this will follow the Markovnikov rule. Let us talk about the mechanism for this reaction. We have here double bond. Now we are reacting with HCl. Okay, so hydrogen is slightly positive and chlorine is slightly negative. So the double bond as a pi bond will attack on slightly positive hydrogen. So the path A here, the hydrogen, say we are adding to this carbon that has the larger number of hydrogen. The result will be hydrogen adding to this carbon here containing one hydrogen previously. So this is the hydrogen we have added. So this will generate the positive charge. Carbocation will be generated, and chloride, the leaving group, will then attack on, or the nucleophile will attack on the plus charge. So the result here will be the formation of the product from path A. This is like this. All right. Now, if it follows the path B, in which we add the hydrogen on the other carbon, right, with a less number of hydrogen, then the result will be hydrogen adding here. So if it the hydrogen adding to this carbon, and the plus charge, now it generated this carbon, and Cl minus will then attack on this carbon here, the carbocation. The result will be the product like this. So hydrogen adding here and chlorine is added here. Now, if we look at this one here, the path A is giving you the carbocation, which is tertiary carbocation, whereas the path B is secondary carbocation. So when hydrogen is added to carbon with a larger number of hydrogen, it will result in the formation of better carbocation. Here, see, tertiary is far better than that of secondary. So that is why the path that follows the formation of tertiary carbocation, that will result in the formation of this major product. So Markovnikov rule, in fact, is the consequence of the better carbocation. So we can explain the Markovnikov rule in other ways. So in two ways. So one is we are talking about Markovnikov rule is about the when hydrogen halide added across the double bond hydrogen goes to carbon sp2 carbon containing larger number of hydrogen. That is the one. In other word, again, hydrogen goes to carbon to give better carbocation. So both are the could be the statement for the uh, Markovnikov rule. Hydrogen goes to the carbon with larger number of hydrogen, or hydrogen goes to the carbon to result in the formation of better carbocation. But however, the regioselectivity, the extent of regioselectivity um, is the other thing that we need to understand. If it is secondary versus primary carbocation, so it will be exclusively only secondary will be formed. If it is tertiary versus primary, exclusively it will be tertiary will be the formation here. But if it is tertiary versus secondary, then tertiary will be there as the major product and secondary will be the minor product. So basically, in other words, primary carbocation is very unlikely to form. That is why either the tertiary or secondary will be the exclusive product, whereas if the reaction is resulting in the tertiary versus secondary carbocation, then tertiary will be the major and secondary will be the minor. That is the regioselectivity that we can mention. Let us see one other example quickly. The implementation of the Markovnikov rule here. Suppose this is an alkene. We are adding hydrogen bromide, and you are asked to figure out what will be the major product on this reaction. So here you can discuss about two possible products. So here again, hydrogen and bromine, you are adding across the double bond. One carbon will take hydrogen, other carbon will take bromine. So the two possible products here are uh, if you add hydrogen to this terminal carbon and bromine to this middle carbon, so that will be the product. And the other possibility here is if we add hydrogen to the middle carbon and bromine in the terminal carbon, this will be the product. But again, based on Markovnikov rule, the major product will be the one that adding hydrogen. So this is the carbon that has two hydrogen, so the hydrogen should go here. So that's where the hydrogen should go, and the bromine will go to this carbon. This will be the major product. In fact, this will be the exclusive product. Now, the other point to be noted, so this is the addition of hydrogen halide. Okay. Now, the other point is this always true for hydrogen halide addition? Is the Markovnikov rule always applies? So, the answer is yes, but except when we discuss that as the other one, peroxide effect. So when we discuss hydrogen halide, HCl, HBr, and HI, these are the three hydrogen halide mainly we discuss. Now, the for HCl and HI, Markovnikov rule always applied. But however, only for HBr and in presence of certain type of peroxide. That is why the name is called peroxide effect. So please remember that. Very important point. Peroxide effect means in presence of some organic peroxide, organic peroxide, and only only for addition of HBr. These are the 2 points that you need to understand. Addition of HBr. Again, for HCl and HI, the peroxide effect does not affect. Only for SBr and only in presence of organic peroxide. Organic peroxide means it will be in presence of some, like say, hydrogen peroxide, but this is inorganic peroxide. So organic peroxide means instead of hydrogen, we have some R group, some kind of alkyl group, R2O2. Or in other word, we can write that as ROOR, this type of organic peroxide. And if we are adding HBr, the addition follow anti to the Markovnikov rule. So the addition follow anti Markovnikov rule. Very important point. Markovnikov's rule. That means hydrogen will add to the carbon with less number of hydrogen, and bromine will go to the carbon with larger number of hydrogen. Only for HBr in presence of organic peroxide. If peroxide is not present, it will not follow the it will follow the Markovnikov rule, or it will not follow the anti-Markovnikov rule. Let us see one example here. So suppose you have this alkene, asymmetric alkene, and we are adding HBr. So if we do not have peroxide applied, just in the ordinary case, it will follow the Markovnikov rule. So here, just only you need to look at the carbon-carbon double bond. Hydrogen will go to the carbon with a larger number of hydrogen. Bromine will go to the next carbon. So the result on this case will be hydrogen will be added here and bromine will be added here. Okay, hydrogen you may or may not show, you know that very well. But if you do the same reaction in presence of organic peroxide, ROOR, okay, organic peroxide, then it will follow anti to the Markovnikov rule. Now this is called again peroxide effect, so you can mention that as peroxide effect. Then hydrogen will go to the carbon with less number of hydrogen, bromine will go to the other side. So this is when you have peroxide, when no peroxide. Okay, so this is Markovnikov product, and this is anti-Markovnikov rule. Markovnikov product. Now, why that happens, why it will follow the anti-Markovnikov rule? The reason is this peroxide, in presence of peroxide, it will follow free radical mechanism that you have discussed in chapter 9, free radical mechanism. Because in the initiation step, it will generate it will generate alkyl oxide as the free radical. Okay, free radical will be generated, and it will follow different type of mechanism. No carbocation formation, but free radical mechanism will be followed. That is why it will give you the anti-Markovnikov rule. Okay, and now the question is why SBr? Because in this case the bromine is very appropriate, or the size of the bromine is very suitable. Br size is suitable for the radical mechanism. Okay, radical mechanism, and that is why it will follow the radical mechanism in this case because of HBr. So remember, HBr in presence of organic peroxide, it will follow anti to the Markovnikov rule. But if no peroxide is present, then it will follow regular Markovnikov rule. It's a very important point to be noted, and this is the main reaction there. Okay, this is again the continuation of the previous one, how the Markovnikov and anti-Markovnikov happens. Thank you.